demonstration around the country. He demonstrates at DEF CON and ShmooCon. He's also done demonstrations for Black Hat, DeepSec, and the United States Military Academy at West Point. Those are just a few. While paying bills as the security auditor and penetration testing consultant with his company, the Core Group, he is also a member of the board of directors of the U.S. division of TOOL, the Open Organization of Lockpickers. Deviant Ollam.
Thank you. Hello, how's everybody doing? All right. I really do appreciate coming here to talk to people like this. It's a little bit of a break from my usual completely black t-shirted, blue-haired hacker scene type conferences, but it's a real important message, at least I think so, and it's a message that should resonate with you, particularly the way I've crafted this little talk and how it applies to professional spaces, not just, hey, oh my God, locks are so bad, look, let's open them. I mean, that's part of it, that's always part of it, because we keep doing it wrong. People ask me, man, Dave, how do you get so much mileage out of this talk? Like I've seen, you update the slides, but some of these, you're reusing this content. I can poke fun at Dan Kaminsky because he's a friend of mine, but it's kind of that model, like getting a lot of traction out of one sort of focus area. And the reason simply is we're still doing it wrong. We are continuing to fail, and that's, of course, a similar theme that you hear all the time in a lot of different sectors. And the physical world, as you will see, is really no different from the digital world in a lot of ways as far as security is concerned. So really quickly, who am I? Well, kind of depends on what I'm wearing when you see me. As the introduction states, I do have my own company, the Core Group. I and a couple other people bang around this country telling everybody what's wrong with their facilities physically. So we do auditing, we do assessments, we even do some forensics after break-ins. But if you see me in black t-shirt mode, I'm usually banging around at some conference with TOOL. TOOL is a nonprofit group just dedicated to helping people have fun and play with lockpicking. And there's, of course, a real valuable side to that, the idea of making you a better consumer, making you understand the products that you're paying for more. But ultimately, we do that just because it's fun. So if you ever see us, come out and say hi. There will be a whole lockpicking table that I'm going to set up out in the lobby after this is done. I want you guys to try a little bit. I brought way too much weight in my luggage for you to just mill around eating some muffins. So please get some hands-on time. I think you'll really enjoy not just seeing this, but trying it yourself. Really quickly, I feel I should just make a note. The last speaker was asked a very good question. Assistant Director Snow was asked, what is your personal definition of a hacker? And he gave what is, I feel, a legitimate, for his circle and in his sphere, an answer. He said, well, the dialogue has changed over the years. The word hacker has become, a new meaning than what it once represented. Words really only have the meanings we give them. So I have full respect for Director Snow and all my other buddies in the Bureau who are fighting the good fight, but I will be one of a number of voices you may hear using hacker the old way. I'm not afraid of that term, and I don't think you should be either. And I really appreciated the question. I thought his answer was good, but I thought your reaction was even good as well. So thank you for that. Don't be afraid of the hacksaws. They are not the bad people you think they are. At least not the word. Hire somebody with it on their resume once, and you can change the dynamic. All right, off my soapbox. That was my other little thing. The other side of my soapbox that we get into in bars is what else I do, a lot of physical security with, little round holes at long distances, and all about firearms and traveling with firearms and flying with firearms. If you ever want to learn a whole lot about how the air system works involving firearms, you can look at a bunch of my other talks or just buy me a beer sometime because it's fascinatingly fun. But on to locks, the reason I was ostensibly brought here today. Locks matter. Locks matter to the people in this room. Even if you don't think your job relies on them especially a whole lot, it actually does. Why? Well, simply put, you can do absolutely everything right when you build your network. You can set up all your firewall permissions. You can segment all the different segments of the net. You have, all right, this is a subnet here. We're going to manage all these switches. If I am red teaming you, if my company is hired, the first thing I'm going to do, well, maybe the first thing I'll do is sit in the parking lot with a Wi-Fi antenna because it's easier. I don't move around a lot. There might be stairs in your building. Come on. But if I have to get in the building, the first thing I'm going to do is not try to, drop CDs and, do freaking little switchblade installs. I'm just going to find the room where all this equipment is, get in that room, and throw a console cable into the first thing I find. And that's it. Game over. Everything you just did, allow any. Goodbye. You can have a PBX talking to another PBX across campus or across the country. Oh, all of our calls, we have this great VoIP system, and it's all crypto and buzzwords, tokens, woo! I guarantee you there's still a bunch of wire in your walls that's just copper, going down to a room that looks like this from everyone's desk, where the PBX is located. I can get into that room probably really easily, and the first thing I'm going to do is just bridge clip a little lineman's butt pack, or even nicer is like an MP3 recorder, and just start capturing phone calls in the clear. It's great on deliverable day when you go in with a whole team of people, and you're sitting at a table, and someone says, well, we found, this is our web application or thing, and we found these vulnerabilities, and someone else says, all right, well, I SQL injected this, and they're showing papers and papers. And the CEO, oh yeah, well, clearly we must have, I guess we should spend more money, right? Because we did something wrong. What is this guy going to talk about? And I just put, play. And it's the CEO like talking to his wife about their daughter. Could you really need a pony for her birthday? That costs too much. And he'll freak the hell out. He's like, how did you get my phone calls? Well, you probably spent $6 on the lock that was on the room where all this equipment is. This is not rocket science. So everything you do here, everything you do right, I hope, is undermined by the guy you send to Home Depot. And he's, oh, well, we need to put another lock on this door. This one looks good. We've got a lot that look like this. I'll get more. So the perpetuation of bad security, just continually being, flooded through all of our infrastructure, has a real problem that loops all the way back into how secure all of your little ones and zeros are. And that's why I talk about this. And hopefully that's why you'll enjoy this, or be able to justify why you spent the late morning listening to this. I thought you were going to be back at your desk. You're listening to that Deviant guy. Well, yeah, because hopefully it matters to your job. So this talk is called the 4 types of locks. And anyone who's seen me or anyone talk about locks before, you say, even as consumers, whoa, there's way more than 4 types of locks. I've seen a billion different key designs and everything else. That's not what I mean. I'm not talking about 4 mechanisms. I, for purposes of a security framework, just kind of group locks into 4 really broad categories. And I think if you think in terms of these 4 categories, you can really, really make an impact in your security posture. Because ultimately, we can spend hours at length, and we do, just discoursing about, oh, this great new design and this thing. Well, this is a little better than that. Oh, they upgraded those pins and this. That doesn't matter to you. You need to be able to quickly and easily categorize the hardware available to you and not know exactly every little bit of minutia of what's functioning inside. But I hope to paint a pretty good picture that you can see, A, why the first category I talk about is awful, and slowly will build up to why I think the last category is really great, and where in between you actually belong. Because not everybody needs to spend $200 on every lock on every door. We'll talk about what matters and what really shouldn't. So what are the lowest grade of locks you're using? Well, I guarantee you the most of them are pin tumbler locks. One of the oldest designs, you can see it in deadbolts, locking doorknobs, even padlocks. These are all very different form factors, but internally the mechanism is virtually the same thing, and it's been unchanged for decades. I would even say for well over a century. The idea of a pin tumbler lock, just a basic, a plug, a round part that turns. And if you look down the keyway, some of you may have even seen little bits of metal. You say, oh, what is that little thing in there? That's the pin. It's one of the many pins in a pin tumbler lock. Many of you know that there are pins in there somewhere. What are they actually doing? How do they hold the lock shut? Or how do they fail to hold the lock shut in an epic way? Well, this is what's really happening if you were kind of to shear away the front of a typical pin tumbler lock. There is one pin that you can kind of get a glimpse of from the outside. I show it in red. That's called the key pin. However, right next to that, shown in blue, there's what's called the driver pin. And that's a pin you should probably never see unless you field strip the lock and take it all apart. The driver pin is what is actually holding the lock shut when it's at rest. So if you have no key in the lock, you can't just reach up and stick a popsicle stick in it and try to turn. The plug won't turn because it's, quote, binding. The driver pin is binding. And it doesn't matter the orientation of how this lock is mounted or where it's mounted. There's a spring holding the whole pin stack in place. How many people have been in Europe or other countries? You see a lot of times what we would consider upside down is the norm for them over there. It's fine. The spring will keep the driver pin and the key pin at rest. If, however, you have the appropriate key, the key that's designed to open this lock, you insert that in, it will push the whole pin stack as it rides through the keyway, ultimately raising it, pushing it into just the right position, where the split in between the driver pin and the key pin is right at what we call the shear line, allowing the plug to turn. Does that make sense so far? All right, you are now fully versed in a lock design that the Yale and Town Company made right at the turn of the century, and we have been using up until, for all purposes, last Tuesday. That is just what we've got. There are many other designs out there. This is the one that's on 90% of your stuff. Now, fortunately, for some purpose of security, it's not just a single pin stack. It's a series of them. You have an array of pins. Notice the driver pins and the springs are all fairly uniform. It's the key pins, shown in red, that have variation in their size. That corresponds directly to the bitting cuts on the blade of your key. So when your key goes in, thunk, if every bitting cut is correct, every pin stack is at the shear line, and the plug is free to turn. Make sense there? And of course, if you have just one pin stack a little out of position, here we have the number 2 position stack. It's a little bit low. Does everyone see that? So the driver pin there hasn't quite cleared. Likewise, if a pin position stack is a little too high, same thing. It's not the driver pin, in this case it's the key pin that's now binding in that shear line, but ultimately that as well will fail to operate the lock. This leads to some very interesting thinking. This leads especially among the IT community. This leads to people saying, well, it's kind of like a password, right? I mean, you have more pins and more stuff. I've seen some keys have like 6 pins, right? Or 7 pins. My new Medico has 7 pins. So it's like longer. That's real good, isn't it? No, not exactly. Yes, I mean, I wouldn't trust a 2-pin lock or a 3-pin lock to much security. They exist. But just thinking purely in terms of, oh, it's like a password, runs you into some really shallow ground, and you can get hung up with that analogy too much. Why? You attack a password all at once, right? You can try to brute force it, but you're going to go through every single possible permutation, unless the joke that we overuse all the time is unless you're in the movies and you're trying to hack the Gibson or something, and all the numbers are all spinning, and like one locks in. Oh, it's a 7 in this position. Oh, look, it's a Z. Oh, he's halfway there. He's going to launch the missiles. That kind of crap. Right. I mean, that's not how passwords work. That's how locks work. Locks are not digital devices. They don't simply lock all at once or nothing. You can't just, brute force everything. That's not the only way to attack a lock. A lock literally is like, cracking encryption in the movies. Why is that? Why can you attack pieces of the lock at once? A little bit here, a little bit there. What's actually happening when someone is, picking a lock? This is what's happening. Instead of a perfect world, imagine, if you will, we've stripped the whole lock apart, and on the left side of the screen, the plug, we've dumped all the pins out, and we're looking at it from above. All those pin chambers, they should be perfectly uniform. I mean, that makes sense. You want all the pins to be the same size. You want the chambers to be perfectly aligned. In the real world, you don't get this. In a perfect place, trying to turn the plug with no key, all those pin stacks would bind, bind, bind. But again, that's not the real world. What is the real world? Well, the real world is one in which consumers buy goods in the marketplace in a competitive sphere of pricing. And if some guy says, I want to build locks and I'm going to sell them, I'm going to form Bob's Lock Company, and that person can't just magic up a product and make it on the store shelf. Anybody who's ever done any physical fab work knows you have to consult with a fab lab or a machine shop. And you say, here's my CAD diagram, I want to produce this widget. And they say, oh, okay. What are your tolerances, madam? How do you want to, how tightly do you want to engineer this? And you say, oh, all right. Well, I can deal with plus or minus like 1/10 of a millimeter. And they say, okay, well, we can have those for you on Tuesday at this and that cost. Well, Bob's Lock Company, when he wants to make locks, Bob says, here's my CAD diagram, Mr. Factory. And they say, all right, Bob, how tight do you want those tolerances? Now, Bob's going to think of this lock. He said, well, they got to be perfect, right? I want all those pins to bind. I want everything to be smooth and perfectly functioning. And they say, okay, well, so you're talking like 1/100 of a millimeter or so? He's like, yeah, that sounds great. 1/100 of a millimeter, and use really hard steel, because locks are security devices. And the factory's like, oh, okay, well, let's crunch some numbers here. We're going to steel, so we're going to have a drill jig and a work piece. We're going to have to change those drill bits probably every half hour or every 1,000 pieces, because they're going to wear out. And the steel's going to cost this. And all right, for that machining, we're going to have to probably CNC mill. All right, that's going to cost you $80. And Bob craps himself. He says, whoa, I'm trying to sell these in a marketplace where they go for like $7 on the shelf. I can't pay $80 to you. The factory says, all right, all right, all right. Well, how about we make your tolerances more like a 50th of a millimeter, and maybe we'll use some brass, because brass is easier to mill, so that won't wear our machines out as much, and we can run the machines a little faster. So, all right, how about a $20, piece? And Bob's like, are you not hearing me? I'm trying to sell these for $7. You got to help me out, guy. Says, all right, okay. Well, we won't stop the line to change the drill jig as often. And maybe those pins, instead of milling them from rod stock, maybe we'll just cast them out of potted metal. That'll knock down the speed. So blah, 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 crunch, crunch, crunch. All right, we can produce these for $3.50. Or we can produce them for $1.50 if, crying children overseas do it. And Bob will say either, whether he's going to sell them in Lowe's or on Deal Extreme, he'll make the choice. He'll say, all right, go with that. That sounds great. And then Bob's Lock Company is born, one of many, many brands just in the industry, serving like all the others do. Well, here's what Bob's locks actually look like if you start taking a typical lock apart. I mean, this was a brand new lock that a friend of mine named Scorch just bought overseas, took it apart. He said, wow, this has had no use and wear and tear at all. But I mean, those chambers, there's a lot of slop in those chambers. The pins were all pitted and scarred up. This is not an example of the worst lock out there. It's not the best lock out there. It's just kind of average. Typical locks have imperfections to varying degree. And it's all because we have to take this diagram and produce it in the real world. Anything machined in the real world will have some imperfection. And because of that, instead of imagine our lock binding with no key, instead of binding everywhere, you wind up with pin stacks that are binding, in just one place. Whatever pin is sort of the most misaligned pin, when you try to turn that plug, it's the first pin that'll hit against the plug wall and the chamber of the housing. That's the only pin binding. The other pins are just kind of hanging out. So if you have locks binding one pin at a time, you can attack a lock one pin at a time. That's what lock picking is. It's putting a little pressure on the plug and pushing on a pin stack until a certain height is reached. If you reach the right height, the height that the pin supposed to have gone with the proper key, that pin stack is no longer binding. Does that make sense? And the plug can actually turn. The lock can't open. The plug will turn just enough for some other stack, the next most misaligned stack, to be the one hitting. But look at the one you've lifted up. That driver pin is now caught on a small lip. It's caught and jammed and will never drop back into the keyway because you've maintained a little bit of pressure. That pin is now what's called set. And if you keep that very gentle rotating pressure on the plug, that torsional pressure with a tension tool like this one, you can go and hunt through the lock, hunt around, fish around, and you're trying to, just exploit the weaknesses. You're trying to gather information. You say, no, this feels really weak. You'll feel the spring, but it won't feel really stiff. You say, no, there's no real binding pressure. There's no friction. Ooh, this felt a little stiff, and maybe you feel a click. You're like, oh, I think I got one. Let's see this one. Nah, this is not stiff at all. Keep looking around. Maybe we'll find a little more binding pressure. Ooh, that felt kind of stiff, and there's a click. So you're hunting around, just trying to find the binding pins and push them very gently into a position where they will stick right at the right height. Notice those key pins, they're going to just keep dropping back in. So don't think you have to look into the lock, because you're all going to try this. I'm giving you pearls here. Don't try to look into the lock and say, oh, I keep seeing the pin falling down. No, it's fine. That pin's supposed to fall down. But when you get the last one, now there's nothing holding it. Whoop, lock pops open. It's absolutely that simple. Every one of you, absolutely every one of you can do this. And if we want to switch to our camera view, because what is a talk without the potential for epic fail? So we're going to try to live demo it up here. As my buddy likes to say, this is either going to be really awesome or really horrible. The absolute value of this talk is awesome. Here's our tension tool. I'm just going to put that in the keyway of this typical, hardware store lock. Very gentle pressure. When you try this, super light pressure and very little lift. I'm using just a hook tool here. If you push too far, you're going to overlift one of those binding stacks and jam the key pin, shown in red. Jam that into the keyway, into the shear line. Nothing you can do at that point except release pressure, let all the springs push everything back. But hopefully, if I stop yapping my big mouth, we might actually even hear some clicks, but I doubt it. I'm pretty sure I pushed one a little far on that time. Maybe if I hold it to the mic, you might even... You hear them fall back down? So I had a couple that were too far. Wow, you can really hear the sweat beading up on my head. And I had to run to a little local lock shop just because I noticed that some of my locks were really beat up on the trip here. You can only pick some locks so often. We have to recycle a lot of our public locks over and over again for the public villages and the public hands-on events. Because those springs give you really valuable feedback. Those will start to wear out. Those will start to really break down. And then the lock, not only will it not function as reliably, but it doesn't give you the appropriate feedback. I'm still just pushing these pins way too far. So nobody, don't pick the one with the yellow tape on it if I don't throw it out before we get out there. But ultimately, even if this doesn't work, you're going to see an even easier technique that will just really blow you away, even lower. I like to show this first because it's kind of the finesse technique, as it were. But something you'll see in a second called raking and other things like jiggling and bumping, absolutely epic for how low-key a lot of your basic security is. I cannot believe, thank you. Diffie's distracted, he's distracting the crowd. Keep tap dance up there, do something for me.
It's like you need a wrist mic.
I do. No, what I really need to do is stop focusing on what I'm doing. A lot of people, when you try this and you're either putting way too much pressure with the tension tool, or you're lifting too hard, or you're thinking about it too much. Don't really concentrate super hard. It helps, it sounds dumb, but if you want to just close your eyes when you're doing it for the first time, or talk to someone else, don't sit there staring into the lock and say, oh, what's not going right? I just can't seem to hit it. You're overthinking it. You're definitely putting way too much pressure on yourself and on your tools. It's a really light touch. We might come back to this in a second. Just because, this happens sometimes. I'd rather this happen than just stand up here with no tools and nothing at all, because it's boring and it makes it seem like this is all, voodoo science. So some of the others will work, and we'll come back to this in a sec. And this is when, I really wish the ShmooCon tradition. How many people get down to DC for ShmooCon? Any show of hands? Like two people? Are you familiar with ShmooCon, run by Bruce and Heidi Potter and the Shmoo Group? They have a wonderful freebie in all of their con bags. It's called the Shmoo Ball. The Shmoo Ball is, ever since the first ShmooCon, it's just been a plush, Nerf ball, and it removes any barrier to kind of interacting with the speaker. Anybody could be timid or doesn't want to speak up. It's kind of a visual bullshit flag. I call BS on that. Yeah, speaker, like right now, if I was at ShmooCon or any good black-shirted HackerCon, I'd just be getting pelted with these Shmoo balls up here. Oh, there we go. Finally. Whew. Thank you. But you see, the less I focus, the more I start telling funny stories and stuff up here. That's what makes it easier. Don't focus really hard. Don't concentrate and really, why is it not working for me? We can switch back. That's just, relax. That's the biggest tip I'm going to give you, and you'll hear me repeating it out there to people just trying out. Relax. It will work. It's really simple, because these locks don't have sophisticated mechanisms in them to prevent this sort of attack. Another attack that's even easier in many instances, called raking. You'll notice some pick tools don't look like little finger-type hooks. They look like scrubby, kind of ripply tools. Those are raking or scrubbing tools or snaking tools. Kind of like fuzzing the lock, if you will. You're putting very gentle pressure on with the tensioner and just kind of scrape back and forth at different angles, and you're trying to catch all the pins. You're trying to just say, well, I'm going to throw a lot at this lock, and maybe this will just work for me. So if we want to try that, maybe it will look a little less foolish. So here we just have a little snake tool here. Sorry, my mic is picking up different when I lean down. So again, just very gentle pressure. Oh, yeah. Yeah, there's your money shot. All right. So again, anybody can do this. This is not hard. Why? Well, again, it's because there are no special protections in these locks. Other locks that you might be using, similar in design and function, but a little bit different in their actual mechanism, called wafer locks. Every filing cabinet, every desk drawer, I'm sure this is where you're encountering wafer locks. How are they different? Well, instead of pin stacks, separate two pins, there are single bits of metal called wafers, and they just can't be too high or too low. They have to be right in the middle, perfectly kind of lined up, allowing everything to turn. even easier to attack, in my opinion, than pin tumbler locks. Not a real sophisticated attack. You're just going to either use those rake sort of scrubbing tools, or you're going to use what are called jiggler tools. And in those instances, again, really simple mechanisms, but we use these everywhere, everywhere, everywhere. So here we have our typical, it's a filing cabinet lock. I mean, you guys have seen all these everywhere. How many people have these in their office right now? I'm sure. You grab a tensioner here. Let's try with just another rake attack here. Okay, well that's open. Let's try to close it with what's called jiggling tools. They're basically, some people would call these repo men keys or auto tryout keys. Not exactly the right name for that tool, but they are used by repo men and car dealers. I'm going to try to lock this back up the other way. Just kind of jiggling and hoping to catch all the wafers. There we go. So that's shut again. Because you don't want to just break in. You want to close everything out on your way back after you've taken photos of the documents and such. Yeah, wafer locks are the biggest boon ever to actual live red team sort of pen testing teams. You can do everything from opening the thermostat and make it really cold or hot in the next day, or to going through every filing cabinet and just taking away documents. So yeah, these locks appear everywhere. Another lock that appears everywhere, combination locks. How many people have ever used this lock? Yes, we all went to high school. Some of us still get to the gym. Clearly, I'm there all the time. So yeah, like the most popular, arguably the most popular padlock type lock in America anyway. How many people have ever seen this lock opened with a shimming attack? Or how many people have ever heard of opening this lock with, let's say, a beer can? Couple of hands. Whoa. Let me switch back to our camera over here. This is the one that really, finally, when people start sitting, they really start waking up on this one because it's so much fun. So, really basic combination lock mechanism. There are ways to decode this. If you kind of pull up on the shackle, you can feel certain sticking points. There's a whole thing I do in my training where you can do a quick mod 4 type math and extrapolate the combination. It absolutely is possible. I don't do that ever because, other than being an academic party trick, it just takes too long. That's at least 5-10 minutes. Where instead, you could just take a piece of beverage can. I'm going to use my little Leatherman tool to cut a quick shape in it. And there's tons of grainy YouTube video of people doing this, some of which featuring my hands as well. I'm going to make a couple folds. So I've just made a little piece of metal like this, and I'm going to insert that down into the side of the lock against the shackle. I'm going to slip that in. There we go. Thank you. Now, if all you're protecting is a jockstrap and some smelly sneakers, all right, fine. I mean, I don't use that lock even in those instances because I don't like really weak security. But fine, I get it. Like, you don't want to spend $100 if the crap in your locker is worth $7. I have seen these on wiring closets. I have seen these in a million places where they absolutely do not belong because people just think, oh, I went to the store and bought a lock last week for whatever. I need a lock this week. And when you don't think of different categories of lock, you just start grabbing stuff that's cheap. And these are all in that first category of lock that I call basic locks, or locks you shouldn't be using. One more pretty bad attack, and then we'll start getting into the better stuff. How are we on time? Doing okay? Yeah. One more attack called bumping. Has anyone heard of bumping? Yes. So this is finally getting some attention in the press. Bumping, the idea of exploiting basic high school physics with the pins. Smashing into one part of the lock will sometimes cause pins to jump elsewhere in the lock. This is what's happening in the lock when a lock-picking gun or a snapping gun is used. Sometimes these show up in spy TV shows and the like. The idea is you're just putting a really strong force into the key pins, knocking the driver pins out of the plug. You can do that with what's called a bump key, just a specially cut key, a key with ridges that are the right shape and the right position. Bang! Smashing them into the lock, either by pulling the key out and driving it in like you see here, or by using a key that's cut down a little further. I mean, I can get into the specifics of it if you want outside in the play area. The idea of just clunk, clunk, really just being able to drive a force right where it belongs and knocking all the driver pins out of the plug so you can turn very quickly. I think I had a bump key demo somewhere around here. Yeah. All right, so here we have a regular lock. Here we have a bump key that does not operate the lock because the bitting is not correct. if I take a bump hammer or any kind of heavy object, you don't need one of these specialized hammers necessarily, very light pressure and a lot of hit. There we go. So that's open. You all can do this. You all can do this because there are no special protections at all against any of these attacks in most of the locks we buy. Where are you using these horrible locks? As you should already guess, you're using these everywhere. You're using these all the time. Outdoor locks, especially locks advertised, ooh, these are ruggedized locks. Well, yeah, they're ruggedized against brute force attacks and maybe even the elements. But, here we clearly in a great part of town. This is what's called, a warded lock. We didn't even talk about warded locks. We can talk about them in the Q&A if you want. Just, again, holding, what does this lever do? Does anyone know? It's the shutoff lever for the entire building's power. A lock that costs probably $4 sitting on that lever. Desk drawers, filing cabinets, these are mostly red team photos with, passwords right on the Post-it note. I did not doctor that photo. That's absolutely how we found it. This, power panels, oh my God, every power panel, it's a wafer lock. Now, you might not be directly responsible if all the power goes out in the building, but it's going to really kind of put a crimp in your day. So it behooves you to walk around for a little bit and say, gee, I wonder where we're using this horrible stuff. All your wiring closets, I'm sure you have equipment that people should not be playing with, probably protected, again, just by wafer locks. So it behooves you to be aware of this and to take stock of what you actually have around your facility. Because I'm sure most of the things that I will find if I walk around your facility are going to look like this. So why are most locks this bad? Ultimately, in the marketplace today, I would blame, it's popular to blame nameless, faceless entities, but it really is kind of a problem of standards. The standards that exist today for locks really don't test locks in real-world scenarios. They don't have things like bumping in the standard. Like the one standard that deals with bumping, the ASTM, actually mentions bumping. Their toughest rating is a lock that, quote, withstands bumping for 15 minutes. What is that? Bumping is a split-second physics-based attack. If a lock is susceptible to bumping, it's going to bump. I don't know what, that must be if, it withstands that for 15 minutes if you forgot your bump key in the car. And you had to go out and get it. And you had to come back all the way up the stairs again, waiting for the elevator or whatever. Pang, all right, I got in. So the way these standards are designed, they don't replicate actual real-world scenario. They replicate use, how many cycles will it go through, and they replicate force. How many foot-pounds of torque before a bolt breaks. Those are all very valid. I'm not dismissing that as the brute force sort of protection. You need to know if the lock is well made. But standards don't really address this sort of scenario, which can be a real risk depending on how sensitive your stuff is. Picking is often an instantaneous attack with a lot of these weak locks. You need to have some kind of response window. You need to have something that will at least slow attackers down so they get noticed, so someone can get down there and say, hey, what are you doing here? What good is a lock that gets people in, let's say, 30 seconds or even 5 minutes if you have a guard who walks around only once every half hour? So you layer your security and you use devices that will slow people down enough as is merited by whatever your door is, whatever's behind it. So let's talk about a little bit better locks. We're going to start stepping it up now. One step up is what I would call pick-resistant locks. How do they make them? Well, changing that keyway immediately is going to change how effective someone's pick tool use is going to be. The tighter, the more narrow, the more curvy and crinkly a keyway is, it really, really can put the kibosh on a lot of basic picking attacks, especially if someone doesn't know entirely what they're doing. I've seen insanely fiendish keyways in the world. This exists. It's an Austrian lock called a Gege. A little bit crazy on the manufacturing costs, but it shows that people are at least thinking. It's a sign that say, wow, we should really take some of this security seriously. Invariably, tighter keyways and the like are going to be paired with what are called either unshimmable lock mechanisms or specialized pin designs. What are those? That shimming attack, literally no excuse for that, in my opinion. Locks today can use non-spring-loaded latch mechanism, because that's just a spring. It's like, a spy, like in the old I Spy TV show. Anybody remember Bill Cosby, the early years? I grew up on this stuff. Like credit card the door, because that's what you're doing. Any kind of slipping attack or shimming attack, you're just pushing a spring out of the way. This is a padlock featuring what's called a double ball. Those steel balls are not going to fall inward unless this control cylinder in the middle, this cam here, is turning. And that's a much more robust mechanism. You can get that just one little step up dramatically changes how good the padlock is you're using. How about picking resistance? Just dramatically changes if you change the pins. If a company is milling pins that aren't simply cylindrical, this is what's called a spool pin. Again, absolutely is going to ruin someone's time, and it's going to make their life harder if they're trying to lift and push. Now, it is possible to pick around some of these anti-pick pins. We can go over that in the public area out there. I'll give you some examples. It just takes a little finer touch. But it's all the idea of making someone work harder. Maybe the guy who is picking your locks is not a seasoned and super trained picker unless you have the nuclear secrets in your office. If it's just some guy who said, well, I kind of snuck in because nobody challenged me and I was able to get up here and kind of look at some files and maybe try to look at some passwords, maybe I'll try to get in this office because some guy learned a little bit of picking on the internet. That happens. Not everyone is a skilled operator. Sometimes it's just, a criminal says, well, I wonder if I can get in this filing cabinet. You can totally stop that sort of person, the novice picker who has just a little knowledge, with something like this. Or something really fiendish like this, like double-spooled, counter-milled pin. That's just glorious. That's a Swedish company called Assa that loves this design, and damn if I don't love them. I don't work for any of the companies that I am praising or shitting on. I try to be pretty neutral about it. I should get that out there. I like good design, and I don't like bad design. Bumping, plenty of ways you can reduce bumping. You guys all understand basic physics. You can absolutely interfere with the transfer of energy if you create gaps, if you create different amounts of mass in those driver pins. A very popular one is this company called Ilco. They make a lot of aftermarket products. A really light, small pin with a very heavy spring. Will it still bump? Yeah, that pin will still fly up and down, but it'll move at such a different rate and speed, it really, really interferes. We have tried bumping. I got a lock to bump once with a single anti-bump pin. And once doesn't count. Once is only like, whoops. Twice, then you get to brag about it later. 2 anti-bump pins, none of us in Tool have ever bumped anything with more than 1 anti-bump pin. It's a 50-cent fix. Your boss sees bumping on the news, says, oh my God, I heard about this bumping, make us bump-proof. Okay, you could spend $80 on every lock, including the broom closet, or you could drop a couple of these pins in, have a locksmith do it for you in one weekend, completely satisfies whatever requirement the boss laid down, made your security posture better, and didn't cost you an arm and a leg. Again, we're just talking about pick resistance. The next level up, what I would actually call high security locks. The skip in between level 2 and 3 is what I really want you kind of taking home. Level 2 locks, those sort of resistant locks, still attackable with the same tools and techniques I am showing you here. Just needs, slower time, more dedication, more finesse. High security locks, in my view, are locks that ultimately cannot be attacked with basic tools and techniques, where some degree of specialization, special knowledge, or special equipment is involved. Let's talk about some of that. One of my popular first ones I ever saw a long time ago, the Schlage Everest design. I liked it. I said, wow, that's kind of neat. It was actually a lock that was called the beer lock at DEF CON, I want to say 12. The lockpick contest that the Colorado crew was running at the time. They said, all right, if anyone gets this lock open, you win a keg of beer or whatever it was. And at the time, no one knew what it was. It was a Schlage Everest. And no one got it open, so Kai Goth kept all the beer. He was very happy. But it's a standard array of pin tumblers, but underneath the plug, an extra pin that will not retract in unless it is scooped up and captured by a long groove on the side of the key. Now, a neat idea. Absolutely, when you first walk into the city, oh, I don't know what this is. I don't know. Really hard to pick. Didn't take long for people to realize that groove is pretty universal, all the keys. So people were just cutting the key and using it as a tensioner, or making specialized tensioners with long fingers. Ultimately, it kind of, died. They also put this nice, Everest logo right on it. It's like, having Apache with the version string kind of showing publicly. I don't really do that, but it's a good effort. The idea of let's not just refine the pins, let's augment the pins. So, I buy that. Side bars, not just side pins, actually having mechanisms interact with the sides of the locks in other ways, really nice security, high security, often impossible to attack with conventional tools. The idea of a series of additional pins that have to lift or even lift and turn all along the side of the key. This is that company Assa with their twin series. In the US, we have the Schlage company making their Primus. That's what the Schlage Primus is. I have one if you want to play with it. Really nice design. It's just auxiliary mechanisms, not just two points of failure together, but two separate systems that layer upon one another. Really good thinking. Sometimes you'll see what are called sliders. If you have tracks running along the side of a key, long grooves, those are usually based in what are called slider mechanisms. This is an Austrian lock by the Eva company. I have one you can play with. And it just feels really smooth. There's no springs in there. Very hard to manipulate those. Some pins will actually turn and allow a sidebar to drop in. The famous Medico lock that many of you may have encountered if you do any government work. Medico locks actually are made by having the pins rotate into position through cross-milled cuts on the key. They're a really interesting design. Again, you can play with some that I have. You can ask me about them later. We want to make up some time here. Neat idea. Just because something, however, is, quote, high security doesn't mean it's infallible. You know, Medico locks, the ones everyone thought, oh, that's such this great high security lock. There's been a lot of attacking Medico going on. Google around for Mark Tobias or Tobias Bluesmanis, or just look around for open in 30 seconds. There's a lot of interesting things that have happened with Medico. They've been very slacking in what their refining process has been. They've kind of extended copyright by making cosmetic changes to this design without really refining and augmenting it for a number of years. And now people can pick Medico, they can bump Medico. Talk to me about that later. Do I think it's still a good lock? Sure. I'd still call it a high security lock in some instances, but I really wouldn't call it, unpickable by any stretch, which is what their literature often refers to. Locks with rotating discs, locks that kind of look like little miniature safes. They absolutely exist. It's a totally different system. Can you attack them? Yes, you can try to reach in with very specialized tools and manipulate those little discs into position. I don't have a whole lot of that you can play with. We bring that out for our big trainings, but ask me about it if you're really curious how some of this works. Is it possible? Yes, but it takes a while. It takes a while and it costs a lot. This tool is not cheap. Ultimately though, there is this one sort of fourth category that I reserve in a very special case. Even beyond what I'd call high security, there's the category of what I would call almost unpickable locks. And that's simply locks that have no known attack or bypass as of yet, publicly posted. So in that rotating disc family, there's a company, the Abloy Group from Finland. Part Assa Abloy is one big manufacturing conglomerate now. They have the ProTech. Ask me during the Q&A for some demos or to play with it. You can really learn about how this is a mechanism that cannot be manipulated open at all. Some locks that involve magnets, particularly magnets from the Austrian Eva company, the MCS, a series of magnetic wheels that have to spin into position when the key is inserted. And because of that, now the whole keyway is just a flat channel because magnetism will radiate out through the plug. So there's nothing you can reach in and touch and manipulate. Amazing security, amazing resistance to duplication of that key. There's only one machine that can make the keys in Vienna. So really just no known attack or bypass. There's a couple of others. The multi-lock has the MT5 series. I have one you can play with. I can explain that out there. Why, is this unpickable category a separate category? Why does it apply sometimes to you? Sometimes you will have a resource that you need to know. You need to know if anyone's ever been in there. No lock is infallible. Someone can just, torch it off the wall. Someone can cut a hole in the wall. Someone can smash the door down. With these sorts of locks, that is the only option available to them. And you show up on Monday and you say, wow, whoa, what's our response procedure? Because you can just put that into action. Safe dials, we're talking again about unpickableness. Safes are rated against different attacks, manipulation attacks, cutting attacks, robot dialers. Ultimately, there is one unpickable safe dial. It's the X series electronic safe dial by the Kabamas company. Ask me outside why this dial is so amazing, and I'll go on at length. Suffice it to say, I'll give you two examples about this dial. Has anyone are you allowed to admit you have one of these at your facilities? Maybe? They won't say, fed. If you spin this dial more than 1.5 times without stopping, the dial shuts down. Why? Human hand can't do that. You have to let go. It knows it's a robot dialer. If you spin this dial and it goes 9, 10, 11, 12, okay, 12 is a number, and start dialing again, it jumps randomly, 57, 58, 59, 50, and it might go up, might go down. So anyone kind of trying to look or anyone installing a spy cam cannot get any useful feedback just watching someone's hands. That's the kind of thinking that goes into this sort of a device, along with many other aspects to it. Ask me outside if this is really something that interests you or something you think might be warranted, depending on the work you do. It always comes back, though, to something I mentioned. Someone said, what about that destructive entry, though? Can't someone just kind of smash their way in? I can put all this money into my lock, and someone can just break through. Well, yeah. But as I say, you're going to know that happened. You will see quite clearly, oh, God, bang, someone was here. The real scary risk is not this sort of an attack. The real risk is when you come in and there's no sign of drilling or, crazy happenstance on your safe or what have you. If you come in on Monday and you say, well, all right, I'm going to work, and my front door of my home office, if you will, oh, that looks great right here. My main office, oh, sure, it's the way I left it. My safe, it's still sitting there, and there was no holes in the side of it. Do you really know, like in your heart, know for sure that no one's been in there? The only way you know is with the highest grade of lock. That's for the, I just need to make someone smash in. What was that, 5? Okay, we're almost there, cool. So again, different locks for different purposes. I'm not saying that basic locks have no purpose at all. I'm just saying be aware that in my opinion, they can be compromised in virtually no time. Pick resistant locks, same tools and techniques, but it's going to take a skilled attacker to get in any sort of speedy way. High security locks, these in my sort of mental framework are things that you absolutely need specialized tools, specialized tactics to get in. And those, quote, unpickable, because we always say that in quotes, unpickable locks, no known attack or bypass. Where are you going to find them? You guys know this already. The dime store stuff, that's probably not going to be great. You can get some pick-resistant gear if you spend a little more at a hardware store. Beyond that, you're dealing with a specialist. You're not just going to the corner shop. You're actually ordering those, quote, unpickables. Sometimes local shops won't even carry them. You're dealing with someone online. It's totally fine if you want to use one of these, on your garden shed where you're just trying to prevent someone from stealing a ladder and a garden hose to make a giant beer bong or something for the weekend game. Well, fine, all right, put that on your house. And again, if your house is all you care about, a resistant lock is probably fine. You got glass everywhere in your house. Someone can smash in. For your actual stuff that might be unattended, something that can be accessed from the outside, a front door, that's where we're talking high security and really sensitive materials for unpickable. Are you protecting against force or finesse? Always keep that in mind. So ultimately, what it comes down to, in my perfect world, there would be 3 types of things you ever have to secure with one of these 4 types of lock. That basic lock in a professional environment literally does not belong. Unacceptable. And that's a lot of work, stripping them out of desks that they ship with and going through your plant ops division and say, come on guys, we got to throw these out. It matters to me, and it should matter to you. Because here's why. The cross-contamination, and I promise I'm almost done right now. What do I mean by cross-contamination? Well, I mean this. If this was just an abandoned parking lot that you own, no facility, you say, I just don't want people parking here because if they park illegally and something happens, then I could be liable with their car, blah, blah, blah. That's fine. Go ahead and just buy this $5 lock, leave it on the chain. You've covered yourself legally. This was not an abandoned parking lot. This was a facility that I was supposed to audit. First thing I noticed, I said, whoa, look at that. Someone went to the store and bought this. And I bet you anything, someone did not just buy this. Because when you send a guy from plant ops to the store, he will not buy this. He will buy this. A pack of them, leave the other 3 in a drawer, and every time, oh, we need a lock, yeah, we got some more of those. They're even the same keying. I didn't go to the trouble of, impressioning that lock out front, but I probably could have done a lot if I impressioned a key. Where else did I find these locks? Well, the main power shutoff had the exact same lock on it, I'm sure, because someone didn't say, hey, this is a power shutoff. Let's put the shittiest lock we can find on this. No, they said, hey, we should really lock this. This is bad. Hey, Steve, don't you have some of those locks in your drawer? Give me one of them. There was a truck in their fleet that the steering column had actually been messed with by someone who tried to steal the truck, and the key was kind of jammed in. There was no locking in the cab. Here's what they did. They put a chain on it with one of these $5 locks, just through the wheels. Absolutely could have taken the truck, driven it away. I don't know what equipment was in the truck. Probably had one of these locks around the back of it. I didn't even look. I was just snapping photos on my phone. Said, oh my God, holy shit. I thought the audit today was over till the last thing I saw. I said, wow, look at this little panel in the dirt. What is that? And sure enough, it was one of those same locks. This was actually a plumbing and piping access panel that had been cut in for a really old foundation. There was a hole in this foundation where they'd cut all this through, big enough for one of my smaller associates to fit in, barred up window. This was the server room. This was the wiring closet. we were able to pick this open, shimmy down inside, bypassing badges and everything else, all because they used, a pack of really bad locks. So keep that in mind. Keep that in mind that there's a different level of security. Everything might look similar, but it's really not. And when you get out there, please come out there, please join us, play with some of this stuff. You will be amazed. You'll be absolutely amazed at how different classifications of lock really can do well or really fall flat. So by all means, come play. Thank you for listening. Thank you very much. I think we burned through our question time on that one. I don't know.
I have a quick question.
Oh, yeah.
Just one. These were all physical locks that you showed.
Mm-hmm.
There are some filing cabinets that have those electronic locks. I mean, there was just one slide you showed with the
auto
cylinder.
dialer?
Yeah. But how about the ones that you could buy for home use that have the key, the codes?
Mm-hmm.
You didn't really brute force any of those. What do you think of those? Thank you.
The question was about, electronic, keypads for simple residential applications and smaller applications. A lot of times they're really bad. Sometimes they're good. Hire an independent auditor, and we'll tell you. Invariably, I will tell you, most of the time, you'll get these sort of home safes or home devices, which will have a keypad or a combo, electronic component, but they'll also have a key override. Has anybody noticed those kind of things? That's because consumers are inherently scared of electronics. They think electronics are modern. Say, oh, this is so neat. What if my power goes out? Oh, then I couldn't, get my jewelry, because you need that in a blackout. So invariably, the company manufacturing that will say, well, to placate the masses, let's farm out, let's source a lock. And they'll source the cheapest thing possible. It's usually a wafer lock, because it's easy to trigger it into a reed switch in the back end. So invariably, a company that makes a device with two routes of access, they'll do one thing really well and one thing really badly. Gun safes are notorious for this. Oh my God, I could do a whole talk on gun safes. They're awful. But ask me about that later outside, but we can have a lot of fun talking about that. Maybe one more and then you gotta wrap it, all right?
One thing I've always been interested in is lock forensics.
Mm-hmm.
So how capable do you think your average Leo is, and is it something you're concerned about when you might be picking a lock?
Yeah. So lock forensics, most law enforcement agencies are not as capable. As I answer your question, I'm actually just going to pull up some images that apply to what you were saying. There is a whole field of lock forensics. What the key touches is not the same as what the pins will touch, what the picks will touch. If you're ever reaching around and manipulating inside of a lock, there are amazing amounts of evidence that you can gather inside of sort of locking equipment, all because of the tool marks that will be left behind by any sort of attacker. Most law enforcement communities are not geared to that sort of evidence collection. They will look for, oh, clearly a crowbar was in this door, but the idea of a facility like a high-end facility, hey, we might have been picked open or bumped open, that's not something they're usually trained to get. And that has real insurance implications, by the way. We have done work, the core group and other companies with us, work on forensics testimony. Our company will say, we had a break-in. What happened? The insurance company says, well, we had somebody picked in, and they took like half of our servers out of the racks and like walked away with them and our data and this and that. And the insurance company goes, oh, really? Wait, how did they get in? Which door did they kick down? Show us, send us photos. Where's the broken window? Well, no, it wasn't that. It was a picking attack. And the insurance company will say, that's not a real thing. We're not paying this claim, 5-figure claim. It's not until one of our associates turns over his or her, testimony on discovery, pre-trial discovery, saying, well, actually, here are my photos from the scope, and this was clearly something was in the lock that didn't belong there. So I can't tell you if it was picked, but someone sure damn well was trying, and the insurance companies will back down, and they say, all right, you know what, we withdraw our objection, go ahead. That has real-world dollars and cents implication if the evidence is not treated right or handled right. It's not just a locksmith that you get in the yellow pages that does that. A forensic locksmith is a very separate field. Contact us or we can point you to someone, or we'll do it ourselves. If you ever really think you're in this situation, it pays to know what to do and what not to do to preserve that scene. Hope that addresses that. One more and then, all right. I feel like I'm eating up too much time here. I'm being rude.
This is pretty much just a continuation of the exact same line. I remember 4 years ago when you talked about the forensics of picking being very easy to tell, but bumping was very difficult. Is that still true?
I was absolutely wrong. I could not have been more wrong. Lady, thank you for bringing that up, because that's something I'm really glad to address. For the longest time, we in the security community thought that bumping, because it's just a key, right? I mean, a key just touches the parts of the lock. Did everyone kind of grasp that? How, normally a key and a pick will touch different things. So there's normal wear and tear from operation, but clearly there are some gashes that are not normal. And you say, oh, this is definitely improper. Well, what about a key? Because, a key just going in and out. Bumping is just a key, right? It's not scraping like this. It's, dragging in and just, oh, what's happening? Well, bumping is incredibly violent on the inside of a lock. Marks like this are not what you'll see. What you'll actually see are these amazing crunch, crunch, crunch stress points all over, stressing the bottom of the key pins. At the right lighting, at the right magnification, you can really see deformities. You can see amazingly bad, impacts. Absolutely all of that happens. If the pins don't jump nice and clean, it'll grab the edge of the driver, it'll misshape the plug hole. So all of that absolutely applies to bumping equally, if not more. So thank you for raising that, and I love when people ask that, because it helps put that myth to bed that I ended up incorrectly instilling in people. So thank you for that, and thank you for listening. Can we do the rest outside? Can we have fun? Can we play out there? Thank you.
So now it's our lunch break, and I'm not going to say that we're locking the auditorium. We're just going to leave the auditorium open. There'll be at least 1 or 2 people in here at all times, but secure your valuables. You know what they are. And we'll be back here at 1 o'clock.